So here we go. We're going to practice what we did yesterday. Sorry about the horrible sound issues that we've been having, but now we should be good to go. So I'll actually maybe go back and delete those videos. The graph of 1 over 2x looks like this. Something about like that anyway. It says to consider the function f of x is 1 over 2x. Find an interval for x values such that the y values will always be within 0.2 of the limit as x goes to 2. So this is difficult to figure out what they're asking for. Here's how you should always draw these problems into understanding. We should state the limit as x goes to what? As x goes to 2 of the function. What's the function? 1 over 2x. Are we allowed to plug that in? Yes, what do you get? 1/4. Or 0.25. Everybody okay with that? All right, so I'm going to mark 0.25 right here. Everybody agree that that's the limit. So what I'm going to do now is I'm going to go over, and that value on the graph happens at what x value? At an x value of 2. Here's what it's saying. We want an interval of x values here such that when we plug them in, all the outputs are within 0.2 of the limit. So if I want to be within 0.2 of the limit, what height would I be at right there? 0.45. And how low would I be? Right there. 0.05. Everybody clear with how I came up with those values? No? Yes. Okay. So I have those values. I want to know what is the x value that would give me a y value of 0.45. How do I figure that out? Take the function and set it equal to 0.45. We're going to figure out where the function is equal to 0.45. We'll multiply both sides by 2x. 1 is equal to 0.9x divided by 0.9. This is 9/10. 1 over 9/10 is 10/9. Everybody okay with how I came up with that value? I'm going to do the 0.05 now. 0.05. Uh-oh. Looks like we're way out there. 1 over 2x is equal to 0.05. What do I do to both sides? So I get 1 is equal to 0.1x. Divide both sides by 0.1. 1 over a 10th is 10. Now, this is what's really important, that we choose the appropriate difference between the x values. For example, what's the difference between 8 or 10 and 2? 8. What's the difference between 18/9 and 10/9? 8/9. We always choose the smaller of the two. We would say that if you were 8/9 on both sides, so let's see, 18/9 plus 8/9 would be 26/9. So if we end up making this our window, it will guarantee that all the outputs are within 0.2 of the actual limit. this graph doesn't bounce outside the top of that window. Yes. I took 8/9 and added it to 2. So 18/9 plus 8/9 was 26/9. Here's what you need to do. You need to identify, we call this value delta. Delta looks like this. The capital letter delta is that. It's a triangle. It's a Greek letter for D. The small letter for delta looks like that. Tomorrow, we're going to look at epsilon values. Today, we're looking at delta values. No. We have to choose whether delta is 8 or 8/9. It's always equal to the smaller. If we would have had delta to be 8, that means we could go all the way from 2 to 10 and from 2 all the way back to -6. That wouldn't work, would it? So you can understand that you have to choose the smaller of the two. Does that make sense? So it says find an interval. Well, your interval would really be x values. You would choose 2, and it would be plus or minus 8/9. That's your delta value. And if you wanted to actually write it, that x is going to be the values between 10/9 and 26/9. That's fine as well. There's many ways to write it. These are all the same. I'm just going to have you choose delta to be 8/9. Always the smallest one. Your answer would be delta equals 8/9. I'm okay with you writing that so long as you understand there's 8/9 on both sides of 2. Does that make sense? You're 8/9 on both sides. Okay? All right. So let me press pause, and then I'm going to hand out your worksheet. And I have it posted. No, I don't. I'll get it out after lunch, okay? Okay, please look at this example. We're going to practice your worksheet problems. Tolerance is going to be our, so like last time we gave you 0.2, this is going to be 1. Okay, so first of all, I'm going to look at my function. It says for the following function, sketch a general graph including the limit and tolerance, and then B, identify the x value needed. So we're going to do that. What does the graph of 2/3 x minus 1 look like? Positive slope, and it goes through -1. And then we go up 2 and over 3. We get a graph. Looks like that. You have to draw the graph. You have to understand visually what's going on, or trust me, you won't understand anything that happens after this. So let's figure out the limit. Can I plug in 3 to this function? What do you get? Is 1, right? So I have a limit of 1. As you plug in 3, it gives you an output of 1. Everybody agreed? As you plug in 3, you have an output of 1. Would everybody agree? So we now want to figure out what would the x values have to be so that we were within a tolerance of 1. So if I go 1 unit up, what would we be at? 2. And if I was 1 unit down, I'd be at So I'm going to take my function and set it equal to what? 2. Add 1, 2/3 x is equal to 3. Multiply by 3/2, and we get x equal to 9/2, or 4.5. Okay, I did 1. Now I got to do the other. So 2/3 x minus 1 is equal to 0. 2/3 x is equal to 1. X is equal to 3/2. 3/2 is 1.5. Finish off this little idea. What's the difference between 3 and 4.5? What's the difference between 1.5 and 3? Those are the same, aren't they? So therefore, delta is equal to 1.5 if you want a tolerance of 1. We'll do the other part when we get back. Go to lunch. Yep. Okay, if we have a tolerance of 0.5, I think this is your question right now, Karina, is we got the 2 here from our tolerance. If the tolerance is 0.5, I move from my limit 0.5. So what would this spot be? 1.5. And then my other spot would be, and I know that your drawing is going to get really messy, you guys. Just do your best, okay? You're gonna do the problem twice. So now we'll do 2 over 3x minus 1 is equal to 1.5. So 2/3 x is equal to 2.5 multiplied by 3/2. So that would be, I don't know, what do you get? Somebody calculate it. So it would be 5, so 7.5 over 2, so 2.25. So this spot right here, that can't be right. 3.75. So this spot right there is 3.75. And then if you take 2 over 3 times x minus 1 is equal to 0.5, we get 2/3 x is equal to 1.5, x is equal to 2.25. So the bigger question is, what is our delta value then? What is the difference between the x value we're approaching and then the two numbers we came up with? 3 to 3.75 and 3 to 2.25. 3/4 of 0.75. Very good. So 0.75 or 3/4, that's the delta value that would ensure that. So one answer here, one answer here. As you change the y values for the window, that changes the x values, correct? Like this last one, we zoomed in all the way to, that's our zoom in. Question, Haley? So when I draw this box there, that's like when we were making our calculator and we were zooming in, right? Okay, so I'm going to let you do that, but let me try to just give you one last idea to help you understand maybe why we're doing this. If you have the limit as x goes to 2 of x plus 1, what's the answer? 3. And that would seem obvious, correct? Now, as you zoom in on this, it always looks like it would stay inside of a nice box, and it would look like it would for sure go to that, right? The bigger question is, how would you know that it didn't do something like this? How do you know there isn't a break? I mean, unless you zoom in all the way, how do you know it doesn't do something like that? Or how do you know it doesn't do something like this? You know, it looks like a straight line, but if you zoom in really far, there's some weird behavior there. So it's not really the value you thought it was. And so in order to ensure that it has what we call this nice behavior, we need to zoom in infinitely small. infinitely small. So right now, you guys are getting values like this, a tolerance of 1, a tolerance of 0.5, tolerance of 0.5, tolerance of 0.2, 0.1, 0.01. Well, we want to eventually get to 1 over infinity for a tolerance and to ensure that we can get small enough. Okay? So go ahead and work on this. You have the rest of the hour, which is a lot more than the other class got. So, yeah, continue to talk and work through it.